Welcome to example number 1. Here we have Sarah, who's pushing on a crate with a force F, 70 newtons, and the crate moves 3 meters. So let's start off with our known information. We know our force is 70 newtons. We also know that the crate moves 3 meters. And since the force is in the same direction as the displacement, we can call that the parallel component of that force. So F and F parallel are equivalent to each other. And we're looking for the work done by Sarah on the crate, which I'll label as W. To solve this problem, we're going to use the equation work equals F parallel multiplied by the displacement D. F parallel is 70 newtons. The displacement is 3 meters. This gives you an answer of 210 newton meters, or you could write it as 210 joules. So 210 joules is gained by the box system by the work done by Sarah on the crate. Just a quick side note about work being done by individual forces. If you were to draw a free body diagram for the box, you would have a normal force, a force F by Sarah, a force of gravity or the weight of the box, and lastly, since it's moving at constant velocity, a backward force known as friction. We just calculated the work done by Sarah, which is 210 joules. So we found the work done by this particular force F. If we were to calculate the work done by the normal force, which I'll label W sub n, that would be equal to the normal force multiplied by the displacement multiplied by the angle between the normal force and the displacement, which is actually 90 degrees. And the cos of 90 degrees is 0. So there's no work being done by the normal force. Also, if you calculate the work done by the gravity, the force of gravity, or the weight of the box, times d times the cosine of also 90 would also yield an answer of no work being done. And lastly, we could talk about the work done by the frictional force. It would be equal to the force of friction, but multiplied by the displacement. Since the friction is to the left and the displacement is to the right, the angle that is made between these two vectors is actually 180 degrees. And the cosine of 180 degrees is actually -1. So this will turn out to be exactly equal to negative 210 joules. Why? Because the force of friction, if you recall the force of the x direction is 0, the force of friction must be equal to the force F. So it's basically equal to 70 newtons. And the displacement is still the same, 3 meters. The only difference is the angle is 180 degrees. So basically, 210 joules is dissipated out of the crate system. So if you look at the work done by the force F, the work done by all of these, and you add all of them up, you get what's known as the net work. And the net work, when you add them up, you'll get 210 plus 0 plus 0 minus 210. You'll get really 0 joules. Why? Because the net force is 0. And if you calculate the work done by the net force, if the net force is 0, then the total amount of work is also 0. So really, in this particular case, the total amount of work for the crate system is actually 0. There's basically positive work being done by Sarah on the crate, and then there's negative work being done by the force of friction. And the sum of those two works add up to 0.